Hello and welcome to Home Lab series on Python and Pandas. In this video, we'll be analyzing the salary levels of central government employees in India. In particular, we'll be looking at what's called the 7th Pay Commission. Now, unlike the demand and the consequent law enactment for salary transparency in the corporate sector, the pay and the salary in central government positions in India is defined strictly by rules. In fact, these rules define the pay so specifically that a Pandas data frame can capture almost all that is there to it. Our objective is to have an hypothetical employee joining at a user-defined position or level on a specific date. The date that we shall be taking shall be on or after January 2016. Which is the date of implementation of the set of rules called the 7th Pay Commission. Based on this, we will build a data frame which contains the month-wise salary of the employee. There will be certain assumptions regarding the promotions of the employee, and on the basis of this, the data frame shall be generated. This data shall be plotted for visualization, and the same shall give us insights like salary progression and the net present value of how much the employee costs the government. From a programming point of view, we'll be looking at the use of packages like Jupyter, Pandas, matplotlib and numpy, data frame operations like filtering, extracting and combining data, and plotting concepts like use of figures, axes and legends. So here we go. This is the 7th Pay Commission pay matrix taken from the Gazette of the Government of India. So this is a screenshot of the PDF, and as you can see that there are levels, that is the column headings from 1 to 18, and there are rows from 1 to 29 on this page and on the next page to 40. So this entire PDF has been punched in the form of an Excel sheet, and the Excel sheet is available for download. The link is provided in the description box. So we will try to understand these 18 levels and 40 rows a little bit more closely. The first step shall be to load the Excel sheet, and for this you need to install openpyxl. Here's my Jupyter notebook. The link to this Jupyter notebook shall also be provided in the description box. As you can see, we can run terminal commands to install openpyxl by giving an exclamation mark before the pip install command, and this installs the openpyxl library. You may also want to install the xlrd library, which is used for reading XLS files, but I shall not be using this further in this code. The first step is to import pandas as PD and import OS. The import OS command enables us to parse all the files which are available in the directory. So as you can see in this directory, I have this Excel sheet 7pcxls. So what I'm doing here is I'm using list comprehension. I do os.list directory to get all the files in the list, and using this list comprehension command, I in os.list directory, I parse through all the files which are there in this particular directory, and if the file happens to have an XLSX extension, or that is it is a Microsoft Excel sheet, then I save it in this file name, and the 0 ensures that only the first such file is saved, which means the 7pc is stored here. And I root pd.excel file name to read the Excel sheet, and xlsx.sheet names to list the worksheets. The first worksheet basically contains the data which I just showed you in the form of a PDF document. Then we can use the pd.readXL command directly to read the file name, and then inside the worksheet I tell it to use the columns A to T. I tell it to skip certain rows, and I tell that there is no header, and I use the level as the index column. I fill in the null values with 0, and when I do df dot info, then I get that the data frame basically consists of 18 columns, and each column has 40 non-null entries, and the data type is either int64, that is integer, or float. So I look at the loaded Excel sheet a little bit more closely. The column headers from 1 to 18, these basically represent the promotions. So when a employee gets promoted from one stage to another, that is from level 1 to level 2, he jumps from here to here. And at a time, an employee can jump only one level. And if an employee has not been promoted, he continues to be in level 1, then it means that each year his salary goes from 1 to 2. That is, his salary increases along with the rows. So these are the index values of my data frame, and these are the column headers. So the column headers basically represent promotions, and the index values represent the annual increment. So each year, let's suppose that an employee is in level 5, he goes from 29,200 to 30,100 and then 31,000 and so on. So now let's take any one particular level 1, and we shall try to plot the salaries of this particular level. So the first step is that we can notice here that some of the values are integers and some are float values. So I basically list out or filter out those columns which have float values, and then I applied this lambda function to convert the data frame columns which have float values also to integer. This is merely for ease in the future operations that we'll be doing. And this is how the data frame looks. I just showed it to you on the PDF a short while back. So now let's try to plot any one particular level. So import matplotlib.pyplot as PLT. So we are using the matplotlib library. The plt.figure size sets the size of the figure. Now we create the y values. The y values are basically df1, means the first column of the data frame, and here as long as the value is not equal to 0, we add it to the y values list. Similarly, we get the x values using this command. So we take all the df.index.values gives us the index values, that is this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 40, and we really don't want to go till 40. We only want to pick up we want to skip the null values in if any, and so we set this from 0 to the length of the y values. So this makes sure that the x array and the y array are of the same length, and if this is not the case, then the plot can actually throw an error. Then we specify these parameters for the line width, color and all that. We also put a label here as level 1, and when we plot this, here's this lovely plot. So you can see that the plot is slightly parabolic in shape, and we will investigate this further a little ahead. So we have learned quite a few things, from loading a data frame from an Excel sheet to plotting a matplotlib plot and setting the x limits, y limits, legends, etc. The next step is that I want to plot the basic pay in all the levels in a single plot. I want to get a plot like this. So to do this, I want to color code the 18 levels in different colors, and for this we'll make use of the fact that the HTML color codes basically consist of a hash and 6 alphanumeric digits. So this FF5733 refers to this pinkish color, while 33 FF5B refers to this green color. So we're going to write this lovely code to generate a palette of 18 random colors. So what this does is that here we have used random choice to generate pick up a random digit from this set of alphanumeric values, and for j in range 6 ensures that I pick this value 6 times, and when I join this with this hash, I get something like hash A4BC92. And this for I in range len df.columns, so this is basically an outer loop which ensures that this inner loop to generate an alphanumeric code runs as many times as we have columns in the data frame, that is 18 times. And this gives us a color palette of 18 colors. We use ax.bar command to plot this colors. You can see that if I run this code again and again, then I get a different color palette each time. So a really lovely way to generate a palette of colors which you can use to make really colorful plots in matplotlib. So the next step is that I parse through each of the columns in the list and store each column as a variable called yval. I use the same trick to create an X array from the index column which has exactly the same length as this yval, and we plot this on the plot. So what we are doing is, first we plot level 1, then level 2, then level 3, level 4. So one by one the various levels are plotted. I add a grid. I add a legend to the upper right. I use the bbox to anchor command to make sure that this legend is outside the plot so it does not clutter up our plot. I add the headings, the X label and the Y label. And there are a few interesting plots. There are a few interesting takeaways from this plot. You can see that typically an entry level employee, the group D employee, joins at level 1. And the pay levels 1, 2, 3, 4, 5, 6, all these are very closely stacked together. There's not much of a hike in case an employee gets promoted. On the other hand, if an employee happens to be a group A officer, he would be typically joining at level 10. And if you see the jumps from level 10 to level 12, 11, 12, 13 is a particularly huge jump. And a group A officer basically recruited through the UPSC would go from level 10 to level 18. And all these jumps are reasonably significant. A group A career basically lasts for 30 to 35 years depending on when you enter the service, and the retirement age is capped at 60. So in these 30-35 years, typically there are 8 promotions. If one goes right up to the apex level, that is 1 every 4 years. So a lot of people have a conception that government jobs offer low growth in India and there's not much work to do. And this typical jibe of low growth and not much work to do typically applies to the lower levels, where you can see that everything is stacked together. But for the group A, there is a lot of jump and promotions all through the career. As I stated earlier, the graphs are parabolic in the shape, and so we investigate this a little further by taking a log of a particular level and trying to plot it. So basically the assumption here is that when we grow in a particular level without any promotions from one year to the other, each year there is a fixed percentage increase. So the salary will be given by the formula of y is equal to starting basic into 1 plus r to the power x. If we take a log on both sides, then we would see the term log 1 plus r, and log 1 plus r can be approximated as r for a very small value of r. So if this assumption about the salary happens to be true, then the slope of the line would be this, and we should get a straight line plot for the salary in a particular level. So to do this, I first take a level which has no zeros, because when you take a log and there's a 0, it throws an error. And when I plot it, it really looks like a straight line. So the next step that we do is that we replace all these zeros with the max value of that particular column. So what happens is that when you hit the peak of a particular pay level, then the salary doesn't increase further. You don't get an annual increment unless you have a promotion. So the reason why this is done is that because the government of India wants the pay at the top levels and the pay at the bottom levels to be retained within a certain ratio. So if you are at one of those senior levels and you hit the pay ceiling, then you don't get an annual increment. Your salary can further increase only if you get a promotion. And you can notice that these promotions are also not very significant. So the first step here is that I replace all the zeros with the max values using this command, and then I plot it similarly as I had done it earlier. As you can see, every time I plotted, the color changes because I have a random color palette at work. So here's how the plot looks. Now since there are non-zero values, I can take a log. So I create a data frame called slope_df, which is basically a log of this data frame without any zeros. And when I plot this, I get a series of straight lines, and the slope of all these lines is 2.9 or 2.8. So basically what's happening is that in case you don't get a promotion, you get an annual increment of 3% no matter what. And the value of 3% looks a little too low, but there's another component of the salary called the dearness allowance, which we shall be exploring in our future videos. So this ends my analysis of the 7 pay commission pay matrix and the plotting of the same using matplotlib. And I hope you realized how useful data visualizations can be in developing takeaways. So the main takeaways that we developed was that purely through data visualization we figured out that the annual increment happens to be a constant 3%, and we figured out that the jumps in salary for a person joining as a staff in the government of India at the lower levels is not exactly very high. The promotions really don't matter much. But if you happen to join through the UPSC as a Group A officer, then you can expect pretty decent jumps all through your career every 3 to 4 years. Thanks for watching, and do subscribe to this channel.